All right, here are the 5.859 notes. So we are going to start with section 5.8, which is squaring a binomial. So what I want you to do is write these down in your notebook: x plus 1 squared, x plus 2 squared, x plus 3 squared, and so on. So these 8 problems. And do the multiplication out, see what you get. And see if you can start to pick up on a pattern to make it a lot quicker and easier to do this multiplication. Okay, so once you have it all multiplied out, x plus 1 squared is x squared plus 2x plus 1. So here's all the answers. So check your work against what my answers are. So what pattern do you see? You should have seen that the middle term is doubled and the second term in the the middle term is double the second term in the binomial being squared. So if you look at this, x plus 1 squared. The middle term of 2x is just 1 times 2. Okay, and then the last term is the square of the second term in the binomial being squared. So this 1 here, 1 squared is 1. And that pattern works all the time. So for x plus 2 squared, it's 2 times 2 to get you 4, and 2 squared to get you 4. And then 3 times 2 to get you 6x, and 3 squared to get you 9 for your last term. 4 times 2 to get you 8x, 4 squared to get you 16. And then the first term is the square of the first term in the binomial being squared. So that's just saying here we have the x as our first term in that binomial, so it's always x squared. And it even works here for the subtraction. When we do x minus 1 squared, this negative 1, it's double the negative 1 for our middle term. So we get negative 2x. And then the negative 1 squared is plus 1 as our last term. So now we're going to use this to help us factor in a little bit. But first I want you to practice squaring a couple of binomials. So try these 6 problems using the pattern that we figured out in the previous slide. You can pause it and then come back to it to play the solutions. Okay, so here's your solutions, right? Just using the fact for x plus 8 squared, the plus 8, do 8 times 2 to get your middle term of 16x, 8 squared to get your last term of 64. And it works for all the rest of these as well. Okay, now section 5.9 is factoring a trinomial square. All right, what a trinomial square is, it is a trinomial that factors into a binomial squared. So, if we look back here, this x minus 7 squared, this is a binomial square, or squared, sorry. And then this x squared minus 14x plus 49, this is a trinomial because it's 3 terms. And it's a trinomial square because if you factored x squared minus 14x plus 49, it would factor into x minus 7 squared. So it factors into a binomial squared. Okay, so all of the trinomials that we made previously in the last slide, what do you see is true about all these? So let's just recall that pattern. So if you divide the middle term by 2 and then square it, you get the last term. The screen shade's being all funky. Okay, so that was all true. If you divide the middle term by 2, square it, you get the last term. Let's just double check that. So let's look back here at this x minus 7 squared again. It got us x squared minus 14x plus 49. So if we take this minus 14x, divide it by 2, we get negative 7. And then if we square negative 7, we get positive 49. So there's the pattern that we're going to use to identify whether or not a trinomial is a trinomial square. Okay, so for example, if I had x squared minus 22, ooh, look, I forgot the x there. This should be minus 22x. So let's see, let's fix that right now. So x squared minus 22x plus 121. So let's just double check that that pattern works. So if we divide the negative 22 in half, or by 2, we get negative 11. Then negative 11 squared is 121. So in this case, this is a trinomial square. Okay, so we can factor this trinomial square into x minus 11 squared. So try these 8. So you're telling whether or not each of the following is a trinomial square, and if it is, you're factoring it, and if it's not, then you're saying why not. So you're going to pause this and then replay it. Okay, here are the solutions. The first one, x squared plus 12x plus 36, factors into x plus 6 squared, because this 6, when you multiply it by 2, you get 12x, but when you square it, you get 36. X squared minus 20x plus 100 is x minus 10 squared, right? And you get the 10, the minus 10, because negative 20 divided by 2 is negative 10, and then negative 10 squared is 100. So it is a trinomial square, so that's how we knew how to factor it, to x minus 10 squared. And then you can just kind of take a look through all of these other solutions, double check your work versus my work. And I do want to point out this one here, x squared minus 8x plus 15. So this is not a trinomial square, because if you take the middle term, negative 8x, so do negative 8 divided by 2, you get negative 4. But if we square negative 4, we get 16, not 15. So we know it's not a trinomial square. Another way to see this, that it's not a trinomial square, is if you look, this plus 15. All of the last terms are perfect square numbers. 15, you can't take the square root of it and get a whole number. So we know that we can't factor it like a trinomial square. This one up here, x squared plus 6x minus 9. I know this isn't a trinomial square. You can test it out using that pattern we found. Divide the 6 by 2, you get 3, but 3 squared is positive 9, not negative 9, so it doesn't work. But also you can recognize it can't be a trinomial square because of the minus 9 at the end. Your last term is never going to be negative, because whenever you square a number, you're always going to get a positive number. Alright, so that's it.